So topology. What is topology? To understand the topology, first we have to understand power set. What is a power set? Power set, consider X is not an empty set. X is not an empty set, then the collection of all possible subset of X, P of X, is called power set. P of X is called power set of X. P of X or power set of X. For example X is not an empty set. Let's take X is equal to X, Y, Z. Then the collection of all the subset of possible subset of X, collection of all the subset of X is called P power set. So, here the possible subsets are phi set, X, Y, set Y, set Z, X, Y, XZ, YZ, and X. So this is called power set of X. So this is the power set of X, because all the possible subsets are in one set. All the possible subset of X is in one set. This is called power of set. Now what is topology? Let X be a non-empty set. Then collection of all the subset of X is a topology on X if it meets three conditions. It's mean the collection of all the subset of X will be on topology on X if the collection of all the set meets three condition. For example, condition 1 that phi and X belongs to tau. What is tau? Tau is the collection of all the subset. Tau is the collection of all the subset of X. So condition 1, phi and X should belong to tau. Condition 2, intersection of any finite member of tau should belong to tau. It means that any finite member, and here we are bounded any finite member of set ta should belong to ta. And condition third is union of any member of set ta should belongs to ta. What is topology? The collection of all the subset of X is a topology on X if it meets three conditions. Condition 1, phi empty set and X should belongs to ta. What is ta? Ta is the collection of all the subset of X. Second condition is that intersection of any finite member of ta, and we know that ta is the collection of all the subset. So in these sets, any two member or three or so on, any member of uh, intersection of any members of ta should belongs to ta, and the union of any members of the set ta should belong to ta. Here in third condition we are not bounded by finite or infinite, while in condition 2 we are bounded. So let's take an example. Let X be a non-empty set. Let take X is equal to A, B, C. So possible subset of, we denote it by ta. Possible subset of X is phi A, B, C, AB, BC, AB, BC, and AC. X and X. So these are possible subset of X, and the collection of subset of that set is equal to ta, which is a power set of X. So we have to know that that is a set ta is a topology on X. So we have to prove three conditions. So we have condition 1 is phi and X is belong to ta. So we have phi and X are belongs to ta. So we have condition 1 is true. Second condition, intersection of any two intersection of members of set ta is belong to set ta is should belong to set ta. So we take any two member from set ta and intersect them. So any two member we take A and B. So intersect it, which is equal to phi set, and phi set is also a member of ta. So V, which is belong to ta, so we have condition 2 is correct. You can check all these members, because if we take C and AB, so we have again intersect them, and we have again we will get set phi. And if we set AB and AC, so we will get and intersect them, so we will get A, and which is a member of set ta. So you can check all of these members. So if we apply condition 3, and condition 3 is union of members of set ta should belong to ta. Union of union, here are we are union. So let's take sets a a and b and intersect them. A union b, which is equal to a b, which is belong to ta. So we have condition third is correct. You can check all of this. So we can say that set ta is a topology on X. I hope you understand it. For more videos, click on subscribe button.